Okay. Now then we are going to look at another type of question. Okay. Okay. Now we have n objects with some identical objects. Now what do you mean by identical objects? Okay, let's say for example, how many ways can two blue balls and one green ball be arranged in a row? The two blue balls are identical and indistinguishable. That means you cannot see the difference between the two blue balls. Now, let's say, for example, I have these three balls like this, two blue balls and one green ball. But then the two blue balls got some cacat one. You know cacat or not? Cacat means they got some defects there. You can got a patch of color, other colors there. So I see this one, I can see the difference between the two blue balls. Okay, so they are not identical. Now in the second case, I have two blue balls and one green ball. And these two blue balls, they are exactly the same. I cannot know what is the difference between them. So you put the two of them together, I cannot distinguish them. I cannot say this is another one, this is a different one. Cannot. They are exactly the same. Okay, so it means that they are identical, right? Now, how many ways can you arrange the balls? Okay, okay, the block. So let's say the two blue balls, they are not identical. So the blue balls, I call them B1 and B2. Then the green ball, only one, so I call them green ball. So how to arrange the three together? B1, B2, G. B2, B1, G. B1, G, B2. B2, G, B1. G, B1, B2. G, B2, B1. So this is the number of ways, right? In which these are the number of ways in which I can arrange two blue balls and one green ball. If the two blue balls, I can see the difference. This is blue ball number one. This is blue ball number two. So it is the same as arranging three different objects. So the answer is 3 factorial. 3 factorial is how many ways? 3 factorials, 6 ways. So, oh yeah, 1, 2, 3, 4, 5, 6. They're together 6 ways, right? However, when I remove the 1 and 2, I have BBG. I have BBG. When I remove the 2 and the 1, I have BBG. So BBG and BBG, are they the same or not? Because the two blue balls, I cannot distinguish them from one another. So I have BBG. So this BBG and BBG is the same. But whereas when they are not identical, they are considered as two different ways. But if they are identical, BBG, BBG, same lah. It is only one way. Any question?
No, teacher.
No. Then, oh, I look at the second one, B1, B2 here. But when I remove the 1 and 2, 1, no more 2, so it's BGB, right? Now, when I remove this 2 and this 1 here, and it's BGB also. Earlier on, when they are not identical, they are two different ways. But when they are identical, both also become BGB, BGB. This is not considered two ways. This is considered one way only, right? Okay, next one. Earlier on, I have G, B1, B2. Now I have G, B, B. Because I don't know the difference between whether it's B1 or B2 or not. They are identical. Now, if I have G, B2 and B1, I still say when they are identical, it becomes GBB also. So I see these two, they are the same. So how to solve this problem? How to count the number of ways when they are identical objects? Definitely, if they are identical, we will have less number of ways. because you see here, right, like that. So these two, they are the same. These two, they are the same. These two, they are the same, right? So what should I do? The first case, in this first case, if they are not identical, of course, three objects, 3 factorial, 6 ways. When they are identical, when the two objects are identical, how to count? How to count? How to get rid of this repeated number of ways? How to get rid of this repeated number of ways? So the trick is like that. Our three objects supposed to be 3 factorial. Because two of them are identical, I divide by 2 factorial. So when I divide by 2 factorial, I have 6 divided by 2, which is 3 ways. Can you count this? 1 way, 2 ways, 3 ways. So I divide. I see how many identical balls. I divide by the number of identical balls factorial. Any question?
No, teacher.
No, no, can understand. Giant, okay or not? I cannot find my. Where is it now? Here. Check. Oh, giant, okay. Okay or not? Okay, giant, okay. Right. So if you know what to do, then we look at more examples. Let's say now I have 3 yellow ball and 1 green ball. The 3 yellow ball, at first they are not identical. They are all different. They got cha-cha here, cha-cha there, cha-cha here, cha-cha there. So they are different. Now in the second case, the 3 yellow balls, no cha-cha, all perfectly the same. How to calculate? Wow. Because 4 objects, and if you remember, 4 objects, you want to permutate them, you want to arrange them, the answer will be 4 factorial. Wow, there are so many ways. I have listed out all the 4 factorial here. Okay, but this one, of this group here, y1, y2, y3 green, they all become y green. All of them become like that. So if there are 6 of them, there are 3 of them here with different one, they have 3 factorial actually here, 3 factorial. And this, not 3, these 3 factorial become one way only, become one way only. When I have this type, yellow, yellow, green, yellow, they have 6 different types if they are different. But if they are all the same, all the 6 different type become one only, become one. And we can group them into 666 where they are all the same. Any question?
No, teacher.
No, can understand. Sure, huh? Okay. Then how to count? If they are different, then it is 4 factorial, 24. If they are the same, then we have to divide by the number of identical objects. There are 3 identical objects. You have to divide by 3 factorial. So 24 divided by 3 factorial is actually only 4 ways. 1, 2, 3, 4. Only 4 ways. So the next lesson, I'm going to ask you how to calculate when there are identical objects. So far, how many times